Morning friends, today I'm going to talk about the prefix conflict. If we have single mapping server or multiple mapping server in the network. So this is the topology for today's lab, where on R3 I have configured multiple loopback like loopback 1, 2, 3, loopback 200, loopback 250, and I'm advertising these entries into the ISIs. We have configured R1 as a mapping server, and then once R1 advertises the index value on behalf of these prefixes, then everywhere in the network, R1 will propagate those entries into the ISIS, and ISIS will spread those entries on the other routers in the network. So today's lab is about the configuring the mapping server, but with the prefix conflict. So this is the first range which I am going to configure, that is 10.1110/28, and this is the second range, that is 10.118/29. This is /29 and this is /28. So for this one, starting index value is 0 and then till 15. Here starting index value is 20 till 27. So here we can see that we have two SID index values for the same prefixes. That's we called as a prefix conflict. When we have two or multiple SID index value for the same prefixes, then we called it as a prefix conflict. And when we have same index value assigned to two or multiple prefixes, then we called it as a SID index conflict. So in the today's lab, we are going to demonstrate the prefix conflict for these prefixes. So let's jump into the lab. So as you can see on the right hand corner, the lab topology and the prefix conflict which we are going to configure. So all routers are running with the ISIS. So this is very simple three router topology. And if we check the routing table, so these are the prefixes which I'm advertising into the ISIS. So loopback 0, the loopback 1, 8, 10, 200, 250. And in the ISIS, I have only option to advertise the prefix seed index value for only one loopback 0 or only one prefix. And then I am redistributing those other loopback interfaces into the ISIS. So if we check the routing table, so the prefixes 10.111, 10.118, 10.110, and 200.111 and 250.111. These are all redistributed on R3. But if we check the L5 table for that, we will not see any SID index value assigned for those prefixes. And even if we check the segment routing table, We don't see any label value calculated based on the segment IDs. Let's trace route to them. So we don't see all these are IPv4. So to mitigate this challenge, we need to configure the segment routing mapping server, and let's configure R1 as a SRMS router, segment routing mapping server. So let's configure 10.11/0/28, and then start index is 0. Range we configured there 15. So let's keep it the same. Then this is the another conflict. So 8/29, range start from 20. Sorry, index value start from 20 and range 10. So if we see those entries, so this is the SRMS configure where we have conflicting entry for these two prefix. And let's configure the 200.111 start, let's say 0, and we don't need any range. Let's configure for 250 as well. And this is the SRMS configuration where we are advertising the segment routing table entries, segment entries, index entries on behalf of R3. Let's commit the configuration and let's see how it reacts. Now if we see the show segment routing mapping server prefix SID map IPv4. Now it is the R1 is advertising these prefixes 10.110/28 with the SID index value from start from 10 and range is 15 till 15. The second overlapping prefix entry is 10.118/29, start index is 20 and range is 10, and these remaining two are with the /32 with the single SID index value. If we check the Wireshark, so we should see that it has advertised those entries into the ISIS. This is the packet capture on the interface between R1 and R2. So where we can see that once we commit this SRMS configuration, router R1 has generated this ALSP. So we can see that we are 4 SID slash level binding TLVs, but 2 are highlighted red. So let's see. So this is saying that /28, but due to some reason it's not showing the entry for that prefix, so it's saying it's corrupted. If we check the second one, that is for the prefix 200.111 and SID or index label value, it is SID slash label value, it is saying 200. And the next one is the for prefix 250.111, SID slash label is 250. The fourth one is also corrupted, but you can verify this is /29 entries for this is for the fourth prefixes. So this way ISIS uses this /label binding TLB to advertise those entry into the IGP domain. If we check the entries on the R2 and R3, so let's check show ISIS segment routing prefix it, and let's check active policy. So yes, R2 got those prefixes, and let's check on the R3. R3 also got these prefixes. Now just check the database and let's see how it's look like. Show ISIS database verbose, so it should highlight all those information. So SID binding is 10.1.1.1.0/28, range is 15, and SID start with 0. Second entry is for 200.1.1.1/32, range is 1, and SID start with the 200. The third entry is 250.1.1.1/32, range is 1, and index value is 250. And last one is 10.1.1.8/29, range is 10, and it start with the value 20. Then all router has received that label, but due to conflict, router is not going to install them into the routing table to avoid the routing loops in the network. So if we check the label table entry for the ISIS, it will just see the entry for the non-conflict prefixes. You you will not see the entry for the prefixes which are conflicted. If we check same status on the R3, so R3 got this only for this. Okay, because it's generated, it belongs to R3, so hence we will not see those entries on the R3 because those entries or those prefixes belongs to R3 router. So R1 we should see those entry, sorry, show ISI segment routing prefix SID label, show ISI segment routing label table. So we can see that entry is only for the non-conflicting prefixes, that is 200.1.1.1 and 250.1.1.1. If we check the LFIP database, we will not see the label value for the conflicting prefixes. So here we can see the prefix 200 and 250 entries in the LFIP table. So same thing we should see on the R2 as well. So we don't see any entry for 10 prefixes which are conflicting, which has the conflicting entries. So if you start to trace route from here, this in trace route will be still using IPv4 because we don't have the SID index or label value for that. But if we take the 200, it's using the segment routing label now. So this is how it works. If the conflicting entries has been configured on the single SRMS router, so SRMS router will advertise those entries. So it is completely depend on those client. Means in this topology, it is completely depend on client, that is R1, R2, and R3, because R1 will act as a client as well as server. So it's completely depend on the R1, R2, and R3 whether to install those entry or not. So in the segment routing, they have provision that the conflicting entries should not be pushed into the LFEed table to avoid the looping or any weird kind of scenario in the production. I hope you enjoyed today's session and thank you very much for watching.